Hello everyone, welcome once again to another Power BI tutorial by Team Slidescope. In this part, you can see we are learning how to create this dashboard on the same health insurance record dataset that we discussed earlier. So in part 1 we created that. In part 2 we will create a dashboard like this where we are using visuals where we can use two categorical fields and one numerical field like average insurance cost by smoking and occupation. Then we are also using ribbon chart. You will understand when and how to use ribbon chart. And here also we have used two categorical fields. Then a variable like age, which was given as a continuous numerical value, we will learn how to create its bin and then create a simple histogram like this, which is not readily available in Power BI. Then we will see usage of a scatter plot and when to use it, usage of a funnel chart and what it means, and we'll discuss some conditional icon putting here that you can see that values that have cities where average cost is low have red, values where average cost is high are green. So we'll see this type of formatting here in table visual, and we'll discuss all of this in this part. So let's get started and begin. So now we are starting our session 2 of this project, health insurance records exploratory data analysis with Power BI. In part 1 we created this dashboard. Tutorial is already uploaded on channel. You can view that. We will simply duplicate. So whenever we have to create another dashboard, either we can create a new page here, okay, and start fresh, or we can simply duplicate. So when you will duplicate, it will give you name like duplicate of part 1. So we will rename it as EDA part 2 or whatever you want to call it. So we will write it as EDA part 2. Now here also I will just write EDA part 2. In part 1 we created KPIs with single variables. So one variable aggregate function KPIs. This is what we did in previous part, right? One numerical variable aggregate function and KPIs. In this part, then we used one numerical and one categorical variable, and we created graphs or visualizations, right, that you can see here like pie chart, bar chart, and different type of charts you can see. In this part we will focus on two things. One is, what if there is one numerical and two categorical variables, okay? What if there, like, we have to visualize this one numerical, two categorical? Then what if we have one numerical, this combination, right? So both variables are numbers. Now in numbers also we have two type of variables. One is categorical, okay, and other one is continuous. Sorry. So one is continuous and other one is discrete, okay. So continuous is something like mass of an object or height of a person, okay. These are example of continuous numerical values, or for example sales. So sales can be any number. In case of discrete, we have values in some interval, like for example over number. If we are just talking about over number, that in over number 1 how many runs, over number 2 how many runs, or number of laptops you have, or number of mobiles you have, or number of people or number of family members, right? So if I ask you number of people in your family, you will answer 3, 4, 5, 6, something like that, right? You will not say I have 3.5 laptops, I have 3.5 phones. So these type of numbers are discrete numbers where you have discrete values. But for example, number of employees in a company, right? These are some discrete example. And continuous is, as I said, sales value, okay? Or continuous is height of a person. It can be anything. Someone can be 160 centimeters, someone can be 180 centimeters, 180.1, 180.2. Everything is possible, right? This is simple. So depending upon what type of number are we talking about, this one-to-one combination will be dealt. So now in part 2, one thing that we will do is we will keep KPIs as they are. Okay. So if needed, we will probably change it because our target field was cost of insurance. We'll keep KPIs as it is, but we will change variables. Now, if you see data, so in data, we have something like occupation. So occupation is business, salaried, or student. So one interesting visualization will be, uh, you know, average insurance cost by occupation. Okay, this can be one interesting visualization. Then let's say we also have smoking status. Okay, so smoking status is formerly smoked and all. So these are variables that we have to visualize. These are categorical fields. So first thing that we are going to do is, because in this part we are going to focus on more fields. Instead of alcohol, we will focus on something like smoking status. So what we are going to do is, from here we will get rid of alcohol from this filter as we created in previous part, and we'll bring smoking status. So now it will change everything as per smoking status. And second, we had cholesterol level. It's just, we are just doing this because we are learning. Actually you will keep all the filters, okay? So that's important. So here we are putting occupation, okay? Occupation can be business, salaried, etc. Now suppose someone asks you to create a chart for smoking status, okay? So smoking status wise insurance cost. But what if they ask you to show smoking status and occupation wise insurance cost? So question is both, you have to consider both of them, like smoking status and occupation. So when we were dealing with one chart, we could have easily created it using, let's say we added occupation on y axis, then we can create average of insurance cost by occupation. Okay. So now what happens is, and we can also see it as a clustered column chart. We can also see it as a stacked bar chart. So now if someone asks you for a second category, okay, second category is what? Smoking status. So what you will do is, in these visuals there is another field called legend, okay? And you should remember that legend is something that represents color, like that represent what is meaning of colors used in this visual, right? This is a legend. This legend is telling us that what is meaning of blue color and dark blue color here, right? So, so your first categorical field will go in your y-axis if it is horizontal, and in legend you will put your second categorical field. Now it will show output like this: average of insurance cost by occupation and smoking status. Okay. Now what is it showing is it has, and this is a stacked bar chart. Okay, a stacked bar chart. In a stacked bar chart, only one bar will be there per category. So per occupation there will be one bar, but this bar will be divided into n number of stacks, and that n number of stacks will come according to legend. So in legend, for example, we have smoking status. Okay, so smoking status unknown, average cost is 28,000. Smoking status, that person smokes, average cost is 26,900. So you can see the difference. And business, or formerly occupation is business, smoking status is formerly smoke, cost is 27,000. This is how it creates. And because we are, you can see y axis, and you can say x axis value starts from 26,000. Here we will start with 0,000 to show them in equal width, right? Here we will start with 0. Remember, if the chart is horizontal, then on y axis categorical field will come, and on x axis numerical will come, right? Then, so first category, second category will go in legend. Okay, so this is, and this is a stacked bar chart. That's why for every bar we will see n number of stacks or segments, right, like this. If we change it to clustered bar chart, then you will see output like this. So now in clustered bar chart, it will create n number of bars depending upon n number of distinct categories in your legend field. So in our legend field, we have 4 distinct values: formerly smoked, never smoked, smokes, unknown. So now it is showing that. Okay. So, and if you simply change it to clustered, you will see output like this. Okay. So yeah, vertical, clustered. So this is one type of output that you can show. If you click on your chart, then you will see this option. It is called focus mode. So when you click on this focus mode, you will see, yeah, obviously it will show in focus. Then you can take it back. Okay. So, and here we can simply write average cost, because we are doing, obviously we are analyzing health insurance cost. So average cost by occupation and smoking. So we can just rename it for any smoking something. Okay. So that heading is in one line. So this is one way of representing two categories. So here we have two categorical fields and one numerical field. We can interchange them also. Like we can take smoking here and we can take occupation here. Then you will see 4 categories here on x-axis, and on your y-axis, or as a cluster, you will see 3 categories. Okay, business, salon. Yes, because it's a vertical chart, then axis position for numerical and categorical will be swapped. So this is important. So this is how you can show. This is one way. Now let's say, let's consider something else. So here you can see we have so many, and this is a great data set because we have so many different categorical fields. So now you can see we have exercise habit. 3 different type of exercise habits are there. Okay, and we also have cholesterol level. Okay, obviously in cholesterol level it is given as a number, but actually it's a category because they have categorized number into 5 categories, right? And we will learn how can we do this. But first we'll start with cholesterol level. Exactly, it is range. So this is very common for variables like age. So in analysis we use age group, right? Age group and BMI group, cholesterol level group, this type of thing. So we'll see. So let's change this. So we will get rid of every value here and we will use a ribbon chart. Okay. So a ribbon chart also has same fields X, Y, legend. This also has same fields X, Y and legend. So what is difference between them? So here on X axis we will keep average insurance cost. Okay. There is one more thing I just want to introduce here. Obviously we will deal with it in great detail. So if I right click here, you will see different options. New measure, new column, new quick measure, etc. etc. So a measure, what is a measure? A measure in Power BI is a calculated value. Okay, it's a calculated value, new measure. So it's something that is not present in our data directly, but we are actually calculating it. Okay, so here, so how can we create it? Right click on your data, right click on your table name, click new measure. Okay, new measure, and this will bring this type of formula bar for you. You can see here, this is a formula bar, right? Here you can write your formula. It's just like Excel. Here you will write DAX, data analysis expressions. This is something that Power BI has for calculated columns, calculated measures and calculated tables. So with the help of DAX, we can create calculated measures. Calculated measures are single aggregate values. Calculated columns are, it's a column, so n number of calculated n number of rows you can see, right? And third is calculated table. So you have one table, you want to create another table by applying some kind of formula on it. We'll learn these things. So today I am just introducing calculated measure, a single aggregate value. Okay. So you will right click here and create new measure and call it AVG cost, average cost. And then we'll use formula. So if I type A, you can see how many functions we have. ABS, ACCRI. You can see. If I type B here, you will see how many functions. C functions, right? So in Power BI DAX, these are functions. There are many functions for different purpose. Okay. So here we are going to use a function called average that we have studied like everywhere, right? Average. Now it will ask you average of what, right? So you are saying that in our data table, okay, there is a column called insurance cost, this, right? Insurance cost. So we will say average of this. So in this function, let's zoom. So in this function, there is average function obviously, then there are parentheses or round bracket. So inside round bracket we have written data. This is our table name. Okay, this is our table name. So whenever you have loaded the data, your table name will be there. So you will use your table name. Then by using a square bracket, right? A square bracket, you will write your column name. This is your column name. And this way we will select a column. So in average function, we are dynamically providing a value field that is data insurance cost. This is a column. So in a function there are arguments, x, y, there can be n number of arguments, right? Some functions have one argument, some have two, some have three, right? So this average function needs one argument, and that argument is your column name. Okay, here average is function, your argument is insurance cost. Because this insurance cost belongs to data, a table called data, so we are writing it like this. Okay, table name, when you loaded the table, so it got saved as data here, because this, and you can rename it also. You can right click and rename. Let's say we are renaming it as insurance. Okay, now we are renaming it as insurance, and if we create a new measure, now we call it AVG cost, right? So we will use average, then we have to write insurance, first your table name, then square bracket, your column name, and then close bracket, and click commit. So then this measure will appear. Okay, so because average cost is already created, it is saying why are you doing this. Okay, so this is measure. To create a measure, you will right click here and create new measure. Right click on your table name, create new measure, then that formula bar will appear. There you will write your formula. After writing it, you will click commit to commit. Okay, we will learn. This is something that you have to understand, right? So for different use cases, we will go through different examples, and there are many sessions on this channel also, and I will take in live classes also, where we will take a data set and we will solve 10 DAX based questions. Okay, and in those 10 DAX questions, 10 different formulas will be used. Sometimes nested formulas will also be used, like putting them together. So this is DAX is the most important thing in Power BI. That is something that makes calculation very easy. But you have to understand it's a basic math. You just have to understand formulas, right? What is it going to do, and you just have to understand a context. In Power BI, context is row context and filter context, which we will see later, but you have to understand it. So that's why right now we are taking a very basic example, that is average. So because every time what we are doing is we are dragging this insurance cost here, and every time we are changing it to average. This is an additional work, right? What if we create a measure here, average cost, that we can directly put here and we don't have to change anything? It's average cost, it's a fixed value, right? it will always show average cost. Suppose we want to create another measure that shows total cost, right? For example, here we were showing average insurance cost. Instead of this, what if we just drag it here? Average cost, right? This is total cost. Let's get rid of this. Right click, new measure. Let's call it total cost, right? So for total, which formula are we going to use? Sum, right? So in sum, then select your table name and just put your value. Sum of insurance cost. So this is a single aggregate value, total cost, and just drag it in your card. Something that we did earlier, right? So this is showing total cost, this is showing average cost. Okay. So this is very important. Now we have used average cost here and we are using a ribbon chart. Okay. In ribbon chart also there is x-axis. So on, and we decided that we are going to create something called on the basis of different exercise level. Okay. On the different, on the basis of different exercise level and cholesterol level, we are going to find out insurance cost. Okay, and see how it varies. So on x-axis you will bring cholesterol level. Okay, cholesterol level x-axis. So now what is it showing us is, for different cholesterol levels, people who have high cholesterol level have higher average cost. So at first glance we can tell that. Obviously difference is very small, but people who have in this range 200 to 225, for very high it is low, but in this range it is high. But here if we bring in legend, let's say exercise, second category, okay, if we bring this, so now it creates output like this instead of something like this. If we compare it with a simple stack chart like this, so we have a big difference here. Here we don't have any ribbon, right? Here we have orange on top, blue, dark blue in middle and light blue in bottom. But here it is all ribbon like khichdi. So here what is happening is, and how to read this, like how to read this and how is it different from that. So what is it telling us is, in cholesterol category 200 to 225, what is rank of insurance cost for each exercise type. So orange is no. So people who are not doing exercise, they are paying highest amount if they have a cholesterol level between 200 to 225. But they are not highest in this cholesterol level, their cost. And their cost is lower in these cholesterol levels, right? So it is showing rank of each exercise level in different cholesterol levels in terms of insurance cost. So so unlike a stack chart where everything is fixed, this is dynamically calculating value on the basis of two variables, two categories, and then showing it like a ribbon that it is highest in this, second in this, lowest in this, right? Rank of exercise no is highest in cholesterol 200 to 225, right? It can be read like this. So this is a very important type of graph which will help us in seeing two category, two categorical values and one numerical value, right? We can check. So we will use this a lot and it is very important for us to understand what it does. So We'll do some other data sets also. In those data sets also you will see, for example, you have a state and you have customer segment, and in each state you want to see which customer segment has highest sales, right? So then also you can use this. It's same as this. In each cholesterol level, we just want to see which exercise category has the highest insurance cost, right? Suppose we want to understand sales, so instead of average cost, we can also bring total cost. Now you can see picture is entirely different. So people who are in the range of 150 to 175, they are paying highest when they have moderate exercise. Okay, so here you can see picture is different, and no matter which cholesterol level category you choose, moderate exercise people are paying highest for different cholesterol. Another thing, if we make it simpler, let's say instead of cholesterol, we just take a variable that has two categories like gender, then you will see just like this, right? For gender it is simple, same values are there. Okay, it's just like a stack chart. So that's what you have to understand, that this chart depends upon what we have selected in data and it gives you output. So till now we have understood how to compare data or how to visualize data when we have two categorical values like smoking and occupation here, like cholesterol level and exercise here. Okay, this. Now what if someone asks you whether higher age people are paying more or low age people are, or people in the lower age group are paying more, right? So age wise insurance cost, what is that? Age wise insurance cost. So how will you create that? Because here age is given as a continuous number, you can see from 16 to 74, right? Age is given, and your insurance cost is also given as a number. Definitely it's a continuous value, you can see, right? So now comes this combination when you have two numbers. Okay, one number versus second number, we can call it. So when you have these two things to visualize, and what if we simply use a bar chart, okay, and just bring age on x-axis, because age is independent and we want to see age wise insurance cost. So insurance cost is dependent, so we bring this here. You will see an output like this, which is very hard to read. What is it showing you is for every age from 16 to 74, it is showing average insurance cost or sum of insurance cost. Okay, if you want to see average cost, you can bring average cost, and it is showing that people are who are very young are paying average cost of 28,000. So it's like that. But and this is valid answer, like you are visualizing it like this. What if we go to format your visual, go to x axis and change it type from continuous to categorical, then you will see an output like this. Okay, so let me show you once again. So here it is continuous. Okay, you go to visual settings, change from continuous to categorical, then it will show in which category you are getting highest value and in which category or age group you are getting lowest value. Okay, so when you will change it to this, but we will follow something else. What we are going to do is instead of using age variable directly, okay, we are going to use age group. So age has minimum value of 16 and maximum value of 74. Okay, just understand this. So age has a minimum value and a maximum value. So this range is very big, right? From 16 to 74. If we change, so it's a range, right? You can subtract them and see what is their range actually right at this moment. But what if we create age groups of 8 years? So what I mean is I will create categories 16 to 24, right? 25 to 33 and something like that, right? So I am creating age groups of 8 years, so then it will be 34 to 42 and so on, right? It will automatically create, and then we will not have those many bins. We will have 5 or 6 bins, right? Easy to understand, easy to visualize. So what, so in Power BI, if you click on a numerical value, these 3 dots are there. Actually it is there for each value, but if you click on this, you will see an option called group new group. So you will click on it. At this moment bin size is 1 years. That's why it is creating so many bins, right? We'll say 8. Now it will create an additional column. So here you can see it has created an additional column. This is age bins. Okay. When we created a new measure, it created this. Here you can see calculator, right? So this is representing a calculated measure. Okay. So if you want to do it once again, let's delete it. Where is delete from model? So right now, if we are dragging age here, you are seeing these n number of bins. Okay. Showing distinct number of ages like we have. We click on these 3 dots and create a new group. This will automatically create a name called age bins. If you want anything, you can use, but in data analysis, statistical analysis, we use this term bins, which is basically group, right? Basically a number of columns that you are going to create. We will write bin size as 10 or 8, whatever, because when we do data analysis for digital marketing, so you have to select your audience, so it is given like 18 to 24, 25 to 32, like that, right? So we are just using 8 here as a number and we click OK. So here we are defining bin size, okay, and when we'll define bin size, then as per data, it will automatically create n number of bins. We don't know how many bins are going to be created. Obviously, we know that because we have the range, but we don't have to worry. So it has created this 8 bins. 1, 2, 3, 4, 5, 6, 7, 8, right? And this. And for all 8 bins, it is showing us average cost. Okay. if we want to see how many customers do we have in each age group, so what we'll do is we'll get rid of average cost and we will just drag applicant ID and we'll select count distinct applicant ID. Now what is this showing us? This is showing us that in each age group how many customers do we have. So for example, in age group 32, right? So this will be 16 to 24, 24 to 32 and 32 onwards, right? So in this age group we have highest number of people than this. So these two age groups have almost same number of people and we have lowest number of people in this age group. Are you getting this? Exactly. And this is called a histogram. Histogram, right? Histogram shows you distribution of data. So here we are showing distribution of age group wise, distribution of age group in our applicant, or in other words we are simply visualizing how many applicants do we have in each age group. But here we can change this number to anything else, right? It can be anything else. So like count of applicant, insurance cost, or whatever. Okay. There we also have their average age, their income, I guess. Let's say we can choose any other number. Let's see what number we can bring. Insurance cost. Daily steps is there, average glucose level is there, BMI is there. So we can also bring average BMI, something like that. I'm just giving an example. Average BMI. So you can see data is distributed in such way that most of the averages are equal, right? Most of the averages. But it will not be true in a real data. It's a synthetic data. That's why it is like that. But in real data, you will definitely see difference. So here we are going to bring applicant ID, that's why, and we'll see. Now if we add something in legend, right? Let's say we want to also see how many male and female are there in each age group, and is there any particular group where we have more males or more females in our applicant. So we can bring gender as legend and then we can see. And here we can go back, enable legend to actually understand also. So here it is showing that this dark blue number is female and light blue is male. To read it in a better way, we can go to column setting, series. Let's say for female, obviously we are going to use pink just to understand. It's not something. So we can clearly see that the pink represents female, and in our entire report we can keep this. Wherever we have male female categorization, or we have to understand, we can apply this color coding. So we'll see. So now this chart is showing so many things. It is showing, it is giving us so many important insights that in age group 16 to 24 we have 1800 applicants, out of which we have this is actually male and this is female, right? But we don't have count. Obviously we can see here that it is close to 3000, but we cannot see that total number. Are you getting my point? Whenever we are taking our mouse over any of these bars, we are seeing numbers but we are not seeing total. So in Power BI there is another field called tooltips. So when you hover over any element and this pop-up that you are seeing where you age, gender is written, yeah. So this pop-up is called tooltip. Okay, this black pop-up is called tooltip. So in tooltip, if we bring applicant count like that, and we bring count string, now when you will take a mouse, you will see that. So it is again changing. Okay, it is changing because it is changing as per our data. So it is changing as per context. Because when context is male, it is showing that data. Okay, so later we will see measures that can bypass this thing, right? That can bypass this filtering. So we'll see. We don't have to go there right now, but I just want to tell that in Power BI everything is possible, right? From calculation point of view. Okay. Yes. So this is a simple data. Or like we have kept this orange and blue combination, so we can also keep the same colors, right? So we can go there in columns and choose this orange so that all colors are same. Maybe this one. Actually, we have used this. Yeah, it's okay. So now it is showing legend that it is representing, and it is automatically showing count of applicant ID by age, bins, and gender. But you can click here. We don't have to call this age bins. We can call it age group, right? So we are only changing in this visual. We are not changing in data, right? We are changing label in this visual only. And here we can simply write applicants applicants by age group and gender, or we can write like hashtag applicant, like number of applicants by age group and gender. So you can change your labels accordingly. So right now what we have seen is we have seen one we have seen two categorical fields like smoking and occupation, and one number. We have seen again two categories and one number. We have also seen changing a number into categorical fields like they have done for cholesterol level, right? They have given us the data in that way, but actually cholesterol level would not have been like this. For every applicant, it would have been a single value, right? What they have done is they have already created a group. So in itself, it is already a calculated column, right? So so you can change numbers into bins. Now there is one more thing, interesting thing here. When we were changing bins, let's edit groups. When we were changing bins, we said we want a bin size of 8. What if we say we want 5 bins? Don't change data or something, right? It can be a case that we want only 5 bins. So in that case, either we calculate that okay, at this moment there are 8 bins. So we start calculating, or we just say instead of size of bin, we just select number of bins. So actually it is creating 59 bins. We say we want 5. So then bin size automatically gets corrected to 11.6 instead of 8. Okay. You say okay भैया 6 दे दो अब 10 है, so we can see, right, 9.6. So we can see this 5, and then it changes to 5. Now it is further, you know, clear. We can say that we can just see in 5 age groups that okay what is happening. So 11, so you can calculate 16 and 11.6, like from 16 to 28 and so on. So depending upon what type of audience do you have, you can do this. Okay, let's move on. So when you are creating a histogram, remember, you can create bins on the basis of number of bins. You can also create bins on the basis of uh, bin size. So, and one more thing, when we have created these bin sizes, 5 bin sizes, so we can use them in filter also, like this. See, 16, 27, 39, 50, 60. These are bin sizes. So, in second bin size, how many people are there? Now, it just becomes a category just like cholesterol level, right? Next is, what if we have to compare two numbers? So we have seen multiple things, one number, two categories, one number, second number. What what if we have to compare two numbers, but we will not change its data type, or we will not change it to category? One number versus second number, and both are continuous. For example, for example, they are taking daily average steps. Okay, will it reduce their average glucose level? We want to see people who are taking more average daily steps. Are they reducing their average glucose level, or they are increasing their glucose level, or there is no effect? Are you getting my point? People who are taking daily steps. So we have 25,000 rows, 25,000 different values of daily average steps. In daily average steps, we actually have 5,000 distinct values. And average glucose level, we have 221 distinct values, right? So if you put x comma y, you can see how many different points it is going to create. So now we will study scatter plot. There is this plot called scatter plot. Okay, what does this scatter plot do, or what it does is, it lets us compare two numbers. So in a scatter plot, you have to use x-axis and y-axis. Okay, just remember, you have to use x-axis and y-axis, and on x-axis you will use something that is independent. So for example, taking daily steps is something that we can do, right? Independent, like we can decide we are going to walk 10,000 steps a day. So independent. And glucose level, average glucose level, this is on y, but what it does is, it just gives us 1 point. What are we going to understand from it? And it is giving sum of average daily steps. It is also not making any sense. Sum of daily step, by all these applicants are there, so we are not going to add their daily step. Right? So in Power BI, it automatically gives you aggregate values out of numerical values, but you can tell Power BI, via Power BI, it is don't summarize. Now you see something, right? You say don't. So if we can see daily average step. So at this moment we cannot see any relation, because we have 25,000 points. But what if we say okay, average? Then we can see something. So for different daily average step routines, from this to this, we have average value of glucose. Okay, which tells us that average glucose level is somewhere in this range, 211. So 118 to 211 for those people who are walking between 4,000 to 6,000 steps a day, right? So, and we can get a lot of details. So let's change it. Let's say average to average. Okay, average to don't summarize. Let's write it like this. Then you are seeing something like this. What is it showing is this is average daily steps they are taking and their average glucose level. Okay, so obviously we are saying don't summarize because glucose level is already average one. So actually you will say don't summarize versus don't summarize to see actually what is happening. And here is a flat line, that means there is no, we cannot conclude anything. But actually you will see, in actual sense you will see average glucose level will be lower for those people who are walking more. Actually you will see that. Okay, so we'll just keep it like this, daily average steps versus average of steps, so that we can see output like this, and it is giving you an output like this. One more thing is there, you can bring legend here as well. Let's say you want to see where are male and female here. Okay, so you can bring gender here as well in legend. So now you can see these dark blues are right, you can see that. And for example we did age bins, so we can bring age bins also here. Obviously we will not be able to analyze this, but for this type of chart, for a scatter plot, I have some different type of data sets that will help us in understanding it in a better way, like what is the actual use of it. In this case it may not be the best chart to create, but at least we are learning things, so we can do that. Okay, then we also have a funnel chart. So what a funnel chart does is same as a bar chart. Okay, let's change it to funnel chart. So this is sum of insurance cost, let's say by occupation. So now what is this funnel chart showing? Or let's say select something which has more values. Let's say city, because obviously we are going to delete city from here, or location. Location. So now what this funnel chart is showing, first of all you can see its shape is like a funnel, right? Let's say we choose, I just want to select something that has 4 or 5 categories, smoking status, so that we can actually understand. Yeah, it's okay. This is good, just to understand. So this is showing sum of insurance cost by smoking status. So in this funnel chart on top, so first of all it is going to arrange in descending order. Okay, so highest value first, then lowest value last, and it is going to show that highest value is 100 percentage of first, like it is going to consider highest value as 100%. Then if you take your mouse to second value, what is it telling us is that this is uh, and if you will take your mouse to third, then it is showing what is it with respect to previous and what is it with respect to the first value, right? It's percentage. So this is a simple funnel chart. And then we have another type of chart, that is table chart. Okay, so in table chart you can see, if we simply will study 2 type of tables. This is just an intro. We are going to do a lot of these dashboards where you will see many different examples of their formatting and customization. Here in a table chart, you will select a table chart. Here you don't have those type of fields. So it is like a calculated table. Okay. Let's say you want to see as we did city wise average cost and total cost. Let's say we want to see both. So we'll bring location, it will show us city, then we created average cost, remember? We'll bring average cost, we created total cost. So now it shows it like a table. Then we can go to table settings, and here we have styles like bold header, right? Like alternate rows. So we have different type of such options that you can try. If we are going with bold header, then in column headers we can select some background color like this, or maybe this, right? For your, and this is called your totals. So this is column header, and in values you have alternate text color, background color. You can change everything. We'll study this. So you can customize their color coding. You can customize everything from here. Okay. So there is a lot to understand here, but you will just today you will just create a table chart to show some data. You can make values bold also like this. You can change alternate text color, like Ahmedabad will be in some color, Bangalore will be in some other color, so like this. You can change alternate text color. So you can make it better, like make it look good. And then there is something called cell elements where we can bring icons, etc. also. I will tell its logic, but I'll just show you that we can bring these things. So for example, in rule, we are saying average cost. If average cost value is greater than 0 to 30%, we'll show it with this color. If it is value is between 0, 31 to, let's say, 100%, something like this. So we'll show it with this color. So you will see now this type of categorization. I will teach this. Don't think that we have already discussed it, but I'm just showing you that we can do something like this. So what is it representing is that in this we went to cell elements where we have these different settings. So in cell elements we have chosen icons. Okay. In icons we are selecting some value. So we are saying average cost. Let's say if average cost is greater than equal to 0 and less than equal to 49%, okay, then we will show it with red, that it is low or whatever, right? Obviously in this case, and if it is greater than equal to 50 and less than equal to 100, then we will show it with green color. So wherever that insurance cost is in that criteria, like it is higher, it is green, it is lower, it is red. Okay, this type of setting, and we'll see this example a lot. Like I will show you many examples. It has, on the basis of this you can show colors, on the basis of this you can show bars. There are a lot of things you can do, right? You can show flags, जैसे कहते हैं red flag, green flag. So those type of things can also be applied, because in icons we actually do have flags. So this is our second part where we have studied more charts, more visuals, I will say. And here, instead of one versus one, we have discussed some other type of charts where we have taken two examples. We have done some customizations also, and we have also done some conditional columns here, like age bin. we have just touched the topic of DAX, that what we can do with DAX. For DAX, there are going to be chapters, right? Like in DAX, functions can also be grouped, like functions related to date and time, functions belonging to time intelligence, functions belonging to finance and sales. This type of grouping is there. Okay, so we'll do that later. Till then, you just try this, and whatever doubts you have, you can discuss in the next class. And those of you who are watching online, you can discuss is discuss with us in the comment section. Till then, have a nice day. Please subscribe to our channel, like this video, share it with your friends who are learning data analysis. Thanks once again. Have a nice day.